Hello everyone, welcome to the video on antibiotics, penicillin. This video is made according to the PCA syllabus of MC3, that is third year, second semester medicinal chemistry. All the topics are covered according to the syllabus one. And this video includes historical background, mechanism of action, nomenclature, stereochemistry, structure-activity relationships and chemical degradation of penicillins. So this is my YouTube channel. I believe learning is fun. You just put my name G. Sai Rajesh in YouTube, you will get the video contents. Let's get into the topic. Now, antibiotics. The word antibiotics is coined by Selman Waxman. He is considered as father of antibiotics. He has discovered streptomycin. Streptomycin was the first known drug to treat tuberculosis. But the first antibiotic was discovered by Alexander Fleming, and that antibiotic is penicillin. This penicillin is discovered in 1928. Now let us understand the concept of antibiosis. See, the word antibiotic is derived from antibiosis. Antibiosis means, understand this word antibiosis. Bio means living organisms. Anti means fighting with each other. What does it mean? Understand this experiment of Alexander Fleming. He was doing an experiment on growing bacteria on a petri dish. Now when he was growing bacteria, accidentally some fungal species has fallen on this petri dish. Now what has happened is, the fungal species started releasing certain chemicals, and that zone where the chemical is present, bacteria growth is inhibited. So Alexander Fleming isolated this chemical and it is found out to be penicillin. So this fungal species is releasing a chemical known as penicillin, and that penicillin has killed bacteria. Now understand the entire concept. What has happened here? Two organisms are there, a fungal species and bacteria is there. Both of them are dependent upon this nutrient present in this petri dish. So there is going to be a competition for this nutrition, and to get that nutrition, fungi started releasing chemicals which is killing bacteria. So this is what is meant by antibiosis. Two living organisms fighting with each other. Anti means fighting with each other. And this is known as antibiosis. You have a similar concept known as symbiosis. Symbiosis means commensal organism. Two organisms living together helping each other is symbiosis. Whereas two organisms living in the same space fighting with each other is known as antibiosis. So with this concept, antibiotic is defined. Look at this. A chemical substance produced by a microorganism which can inhibit the growth or kill another organism. This is what is the definition of antibiotic. If it is inhibiting the growth, they are known as stats. If the growth of bacteria is inhibited, it is known as bacteriostatic agent. If the chemical is killing that microorganism, it is known as cidal agent. That means bactericidal agent. Understand the difference. So stats means that will stop the growth. Cid means that will kill the organism. So this is the historical introduction about antibiotics. Now, let us see about beta-lactam antibiotics. See, the word lactam indicates cyclic amide. See, give me a second. Now, amides are this one. When this amide bond is cyclized, it is called as lactam. That is what happened here. So, see, the typical beta-lactam ring is this. This is an amide link. And this amide link is cyclized, and the cyclized amide links are known as lactams. Now, according to this organic chemistry, the carbonyl carbon adjacent carbon is known as alpha, the next carbon is known as beta. So in the cyclization process, you have two atoms are there, alpha and beta. Because of this, it is known as beta lactams. It has got a cyclic amide, and alpha and beta carbons are there, hence it is known as beta lactam. Now this beta lactam ring is known as pharmacophore. Pharmacophore means a group or ring responsible for the major mechanism of action. So in order to show its action, this particular ring has to be present in the structure, and that is what is known as pharmacophore. Now, getting into the mechanism of action, see, all these beta-lactam antibiotics inhibit cell wall. Cell wall is present in bacteria. Cell wall has got multiple functions. Cell wall, say if this is the cell of bacterium, it is externally protected by a wall like structure, and that is what we call it as cell wall. Cell wall has got certain functions. It will help the microorganisms to survive in extreme pH. When the bacteria gets into the human blood, the pH will be around 7.2 to 7.6. That pH is detrimental to the bacterial survival. The other one, there is high osmotic gradient in human cells. In blood plasma, there is high osmotic gradient is there. To withstand that osmotic gradient, the cell wall will help the bacteria. The other one, human cells also contains lysins or lysozyme. Lysozyme is an enzyme which will digest the bacteria. To help bacteria withstand all these external forces, this cell wall helps them. So cell wall is essential for the survival of bacteria, and the cell wall is inhibited by beta-lactam antibiotics. Once this cell wall is inhibited, the cell death occurs. So this is what is the significance of cell wall. So all beta-lactam antibiotics inhibit cell wall and they cause cell death, hence they are considered as bactericidal agents. Now, when you see the chemical name, this beta-lactam, chemically it is nothing but azatidinone. Aza means nitrogen. On indicates double bond O. So azatidinone, beta-lactam's IUPAC name. Moving further, now see, we have 4 different classes of beta-lactam antibiotics are there. Penicillins, cephalosporins, carbapenems and monobactam. See, all of them contain this beta-lactam ring. As I told you, this is a pharmacophore. That means this ring is essential to show the activity. Along with that ring, in penicillin you have a 5-membered thiazolidine ring is there. In case of cephalosporins, a 6-membered dihydrothiazine ring is there. Carbapenems has got a carbocyclic ring is there. Monobactam, as the name indicates, mono means a single ring is there and that ring is beta-lactam ring. All of them are considered as beta-lactam antibiotics. The common structural motif is beta-lactam ring. Now, let us see the details of this mechanism of action. So, they inhibit cell wall synthesis. How? By inhibiting an enzyme called as transpeptidase. Inhibit the process of transpeptidation of peptidoglycan. Now, this transpeptidase is an essential enzyme to form cell wall. The cell wall structural unit is peptidoglycan. Cell wall is made up of a structural unit known as peptidoglycan. See, this peptidoglycan has got N-acetyl muramic acid and N-acetyl glucosamine. These repeating units are cross-linked with the help of a pentapeptide. So, these repeating units are cross-linked by a pentapeptide, and this pentapeptide, this bond is made by transpeptidase enzyme. So, this enzyme is essential for making this cross-links, and with this cross-links, the strength of cell wall is inhibited. Now, penicillins inhibit this transpeptidase enzyme. So, that is what is that? They inhibit transpeptidation of peptidoglycan. How? This transpeptidase enzyme has got a lysine to which penicillins will bind. Lysine has got a positive charge. It is and this positive charge is bound with this penicillin carboxylate anion. And this binding inhibits transpeptidase enzyme. When the enzyme is inhibited, cross-linking is inhibited. If the cross-linking is inhibited, the entire peptidoglycan is inhibited and cell wall is inhibited. This is how all beta-lactams act. Now, the reason why, see, this is a typical beta-lactam penicillin structure. If you see the structure, the beta-lactam of penicillin is made up of 2 different kinds of amino acids. This amino acid is cysteine. This amino acid is valine. So, because of this amino acid structural similarity, it goes and binds with transpeptidase enzyme of the bacteria. So, this is how beta-lactams will inhibit the transpeptidase enzyme. Now, let us see the nomenclature of these penicillins. Now, according to chemical extracts, the sulfur is given priority and the numbering starts from there. And the total the ring is made up of 7 atoms. Whereas United States Pharmacopoeia, the numbering starts from nitrogen. And this numbering is widely used. The reason is, see, these are bicyclic compounds. Bicyclic compounds means 2 rings are there, A and B. And at the 2 rings, the junction is known as bridge. So this is where 2 rings will combine, and nitrogen is at bridge head. So usually bridge heads are given preference in bicyclic nomenclature. Hence, the United States Pharmacopoeia numbering is followed, wherein the nitrogen gets numbering 1, 2, 3, and at the fourth position sulfur is there, 5, 6, totally 7 atoms are there. Now this is the common structure of this ring is known as penams. Without any substitution, only the bicyclic ring is known as penams, which is also known as penam is there. If with the side chains, it is commonly known as penicillinic acid. Now let us understand the chemical nomenclature of these penams. See, this is a penam ring. If you understand the IUPAC nomenclature of penam, you can easily name any penicillin with the substitutions. Now look at this. This bicyclic ring is called as 4-thia-1-aza bicyclo 3,2-heptane 7-O. Let us understand this in detail. See, we have seen according to USP the numbering is given like this, and at the fourth position sulfur atom is there. That is what is given. At fourth position thia, sulfur is there. At first position aza, nitrogen is there, and it is a bicyclic ring. So 4-thia-1-aza bicyclo talks about at fourth position sulfur is there, at first position nitrogen is there, and it is a bicyclic ring. Now 320 is based on how many atoms are there in this bicyclic ring formation. If you see this is the fused junction, the bridge junction, and surrounding this you have 1, 2, 3 atoms are there, hence it is called as 3, and the other side you have 1, 2 atoms are there, hence it is called as 2, and in the bridge is made up of only 2 atoms, a carbon and nitrogen. So when the bridge is made up of only 2 atoms, it is considered as 0. In certain compounds the bridge is made up of 3 atoms. If you remember, the atropine has got, see, here you have 1 atom, this is second one, this is third one. So usually bridges are made with only 2 atoms. If only 2 atoms will make the bridge, it is considered as 0. If one more atom is there, it is considered as 1. In atropine, you say it as 1. Similarly, when you count, this is 1, 2, 3 are there. Here, this side 3, here 1 and 2 atoms are there. And in the bridge, you have 1 atom is between there. So atropines, it is called as 3 to 1. Whereas in case of penams, you have only 2 bridge atoms are there, hence it is called as 0. 7-one, at 7th position a ketone group is there, hence it is called as 7-one. So this is how we name the parent penam rings: 4-thia-1-aza bicyclo 3,2-heptane 7-one. Now if you know the penam thing, you can name anything with the substitutions. So this is 6-amino penicillinic acid. This is popularly known as 6-APA. 6-amino penicillinic acid. Let us see the IUPAC name. See, the preferred names starts from this one. Now you need to understand certain things. Whenever IUPAC nomenclature is given, it all starts with stereochemistry. First you need to talk about stereochemistry. Now stereochemistry comes when there are asymmetric carbons are there. Now in this ring you have, see, this one is an asymmetric carbon, this one and this one. Asymmetric carbon is a carbon to which 4 different functional groups are attached. So at second position asymmetric carbon is there, you need to talk its stereochemistry. At fifth and sixth position also you have asymmetric carbons. So it starts with stereocenter configuration. Now after that you need to explain about substitutions. Now understand the difference between substitution and functional group. The most reactive group is known as functional group, the remaining all considered as substitutions. Now see what all substitutions you have. You have an amine substitution, methyl substitution and a keto substitution is there. So amine is there, keto substitutions are known as oxo, and then methyl substitutions are there. These substitutions should be named according to alphabetical order. Alphabetical order, A comes first, M comes second, and then oxo comes third. So first you talk about amino substitution, it is present at the position 6. And then you talk about methyl substitution which are present at position 3. And then you talk about keto or oxo substitution which is present at 7. So the next important thing is parent ring. See, after stereochemistry and substitution, we need to explain about the parent ring. Parent ring just now we have seen. It is named as 4-thia-1-aza bicyclo 3,2-heptane. Now understand why it is called as heptane. Totally 7 atoms will make this bicyclic ring. So usually when 7 carbons are there, it is called as heptane. In bicyclic nomenclature, the number of atoms which make this bicyclic ring are considered and accordingly it is named. 7 atoms will make this bicyclic ring, hence it is called as hepta or heptane. Now finally, see, after this parent, if any unsaturation is there, you need to explain about unsaturation, but here you don't have any double bonds or triple bonds. And the final one is functional group. So what is the functional group here? The most reactive group is carboxylic acid and it is present at second position. Hence it is known as 2-carboxylic acid. So this is what is the IUPAC name. Understand it properly. First we need to explain about stereochemistry, then the substitutions, then the parent ring, and finally functional group. Moving further, now let us see the stereochemistry of penicillins. As I told you, the stereochemistry, the stereo centers are present at 2nd, 5th and 6th carbons. Right? When you see the entire structures, you have a bicyclic ring structure is there, a carboxylic group is attached, acyl amino side chain is attached in most of the penicillins, and carbonyl group is present at beta-lactam ring. Now, at 5th and 6th carbons, the hydrogens are present in cis arrangement. See, both of them are below the plane. That arrangement is called as cis arrangement. Now, at this 6th carbon, amine group is present in. Now, at this carbon, the amine group is present in above the plane. It is called as alpha configuration. Whereas at 2nd carbon, carboxylic group is present below the plane, which is known as beta configuration. So, both of them are trans to each other. So, when you read about the stereochemistry, you need to mention only about asymmetric centers. At 2nd carbon, at 5th carbon and 6th carbon, asymmetric centers are there. At 2nd carbon, carboxylic acid is present below the plane. At 5th and 6th carbons, both the hydrogens are present below the plane, cis to each other. Whereas at 6th carbon, amine group is present below the plane. So alpha acyl amino, at 6th carbon, the acyl amino group is present above the plane. Whereas carboxylic acid is presented below the plane. Both of them are trans to each other. Only 2 points are there. Now let us see the structure-activity relationship of penicillins. Now see, the strained beta-lactam ring is essential. So this is beta-lactam ring. When it is combined with another ring, the strain in this ring increases, and that is what is required. The strain increases the activity towards bacterial transpeptidase, so it is essential. Now the free carboxylic acid is essential. I have already discussed about this. This carboxylic acid binds with transpeptidase lysine group, which has got a positive charge. So it is required, essential. Now the bicyclic system is essential because it increases activity. That is what causes strain, and that increases activity. Now acyl amino side chain is also essential. See here, an acyl amino group is there, and this group is essential. This is also essential for activity. Now sulfur is not essential because we have seen carbapenems do not have sulfur, but still they show activity, so it is not essential. Now the stereochemistry of bicyclic ring with respect to acyl amino side chain is important. See this one is in beta configuration, this one is in alpha configuration, and this stereochemistry is essential to show its activity. So this is what is structural activity of penicillins. Now, chemical degradation. See, all these penicillins in presence of acid base or the beta-lactamase enzyme which is produced by bacteria. All these things will open this ring at this junction, beta-lactam ring. Look at this, the ring got opened and you get penicilloic acid. So all of them inactivates penicillin. So this is the major pathway by which resistance is observed by bacteria. Bacteria releases beta-lactamase or penicillinase enzymes that will open this ring. See, this ring is a pharmacophore. Once the ring is opened, you don't see any activity and the penicillins will become inactivated. Similarly, amines and alcohols also react and opens this ring. That is the reason why aminoglycosides should not be given along with penicillins. Aminoglycosides contain an amine ring which will react with penicillin and opens this ring, and that inactivates the penicillins. Now the last one. See, this penicilloic acid undergoes decarboxylation and gives penilloic acid, and it is converted to penilloaldehyde and penicillamine. All these are major pathways, major metabolites in presence of acid. This penicillamine is also act as chelating agent. So the major products observed with chemical degradation is penicilloic acid, especially in presence of acid, penilloic acid, penilloaldehyde and penicillamine are seen. Now one more thing, this penicilloic acid may combine with proteins and becomes penicilloyl proteins. These penicilloyl proteins may be antigenic in nature. One of the major adverse effects of penicillin is hypersensitivity. That hypersensitivity is because of antigenic penilloic protein formation. So these are all the important things in chemical degradation things. In presence of acid or base or beta-lactamase, The ring is open to give penicilloic acid. In presence of acid, the major products are penicilloaldehyde and penicillamine. Now, this penicilloic acid, when it combines with proteins, it forms penicilloyl proteins which may be antigenic in nature, and that is what causes hypersensitivity. So, this is about penicillins. All the topics are according to PCA syllabus. If you like the video, do subscribe and share. Thank you for watching this video.